Welcome to another introductory lesson on R. Today we're going to be talking about what I like to call flow control. Basically, how do I control logical statements to do if-else loops and that sort of stuff. So to begin with, let's talk about logical statements. A logical statement in R is basically just some sort of comparison between one object to the other and whether or not they're equal, less than, greater than, things like that. So to begin with, I'm going to have this object which takes on the value of 7. Now I want to say, does that object, is that possibly equal to 3? Now notice that this is a double equals. So the assignment operator was a single equals, and the comparison operator is a double equals. So I read a single equal sign as gets, and I read a double equal sign as is equal to. So the question becomes is A equal to 3? And the answer should be false. We could ask, is it less than 10? That should be true. Is it less than or equal to 7? That should be true. Is it not equal? So the exclamation point is the not operator, which basically negates whatever the previous logical outcome was. So the equals, so this is not equals to 7. So that should be false because it's equal to 7. Is it greater than or equal to 10? That's also false. And is it greater than 10? That's also false as well. So the logical operators are what you would expect it to be, other than the double equals. That's usually a little confusing. And the not equals. These logical expressions work on an element by element basis if you're going to use them with a vector. So now we're going to change A from being a scalar to being a vector, and I'm going to ask the same sorts of questions. I'm going to ask, is A equal to 3? So now this is going to be a vector of logical values, and the third element in that vector is going to be a true because that was the 3. So the third element was 3. Everything else was different, and therefore is false. A less than 10? Well, all but the last element is less than 10. So you get 9 trues and then a false at the end. Which element is not equal to 7? Well, that's going to be true for everything except the 7th element here. So logical expressions work with vectors on an element by element basis. Now I can combine some logical statements here. So 3 less than or equal to A. So that's going to give a set of falses for the first 3 and then a bunch of trues. Now I can combine this with this other logical statement of A less than or equal to less than 7, where the last 4 are false. So this AND statement says, give me all of the values such that they are greater than 3 and less than 7. And so this is sort of making a compound logical statement using the AND. So for a thing to be true, it has to be true in both the left-hand side and the right-hand side of this logical statement. Alternatively, there is an OR statement where a vector or an indice will be listed as being true if it's true on either this first logical expression or the second logical expression. So this gives me the first 2 elements and the last 3 of them. Now, in general, I usually try to write my logical statements using less than signs instead of greater than signs. And that's so that as I write the statement, I sort of have everything organized where the smallest values are on the left, the largest values are on the right as I read left to right. I think it is a little bit more readable. There are also some functions that take a vector of logical expressions and summarize them. So all will return true if all the elements in the vector are true, and any will return true if there is any of the elements in the logical vector that are true. So in this case, I'm going to go ahead and look at this set, and I've got true, 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 and then a false. So all is going to return a false in this case because they're not all true. Whereas in this case, where I use the any, there is at least one true value in there, and so this will return true. And then the last thing is this not function. It can be applied to a vector of logicals. So I can take this value and this will flip the true to be a false and the false to be a true. Now, the one final thing that I want to mention at this point is sort of a quality of life thing. I want to be able to grab rows of a data set if I've got A's or B's. So I could do some sort of command like this. So let's go ahead and look at my data frame. And I've got 2 A's, 2 B's, 2 C's, and 2 D's. And I often find myself saying, hey, I want to grab the A's and the B's. And I could use a filter command where I create a logical expression that says, this, if type is equal to A, that'll give me a true, or type is equal to B, that'll give me a true. And so this will return a data frame where I just grab the rows that have an A or a B for the type. But this is oftentimes really annoying when I have, say, 5 or 6 elements that I want to be able to grab. So the function %in%, this says this will create a logical expression where it'll return true for any of my type column that is A or B. It gives me the same output, but it's a little bit easier to write or a little bit more succinct. The if-else command is actually quite handy, and let's take a little data set here where I've got a name column, a gender column, and a party column. And the gender column is coded with zeros and ones. And what I'd really like to do is I'd like to do some sort of thing where if it's a 1, I want to have my gender be male. And if it's a 0, I want the gender to be female. So I sort of want to do this if A, then this, if B, then this. So I want to do this quick little trick. Now, the if-else command, it takes as its first argument a logical comparison. So this gender equals 1. This is going to generate a vector of trues and falses. So it'll generate a true, false, true, false, true, false vector. And for everywhere it evaluates to true, I'm going to put in male. And everywhere that it evaluates to false, I'm going to put in the female. So the if-else command has a logical statement, the true value, and then the false value. So let's go ahead and make our second column, our gender 2 column. And everywhere we had a 1, we put in a male. Everywhere there's a 0, we put in a female. Now, this is a really nice vectorized version of an if-else command, but oftentimes I want a very general version for a programming sense. And most programming languages have some version of this if-else command. So let's go and show what this looks like. So in R, it looks like the keyword is if, and then open parenthesis, and then this is some sort of logical expression that it should evaluate to a true or a false. And just a single true or false value, not a vector of true and falses. And if it evaluates to true, then we will execute whatever lines of code are in this expression. There is an optional else part where if this logical test evaluates to true, we do this first chunk. If it evaluates to false, we do this chunk. And so this gives me a way of executing code depending on what the state of this logical test is. So now we're going to do a little example showing how to use this if-else command. So I'm going to use this command sys.date to discover that it is currently August 19th, 2020. And it turns out that the day of the week for today is actually Wednesday. Now, I've got a little chunk of code here that says if it's the weekend, if it's Saturday or Sunday, then I should go out and play. But otherwise, if it's the week, then I need to get back to work. So because today is in fact Wednesday, I should get back to work. The if-else statements can actually be nested and give me more than 2 possible outcomes. So here, if it's the start of the week, if it's Monday or Tuesday, then I'm going to print out that it's the start of the week. If it's Wednesday, it's hump day. If it's Thursday or Friday, then here comes the weekend. And otherwise, if it's Saturday or Sunday, then I'm going to print out that it's the weekend. But because it's Wednesday, it's hump day. So in this case, I can have multiple different ways of executing my code depending on some logical expression. I need to be able to repeatedly run sections of code. This is called looping. Now, basically, this is how do I run repetitive tasks over and over and over again. And if I find myself copying and pasting code, then I oftentimes want to figure out how can I write the code using loops. There are two major types of loops. There's a for loop and a while loop. We'll start with the while loop. The basic structure of a while loop is there is some sort of logical test that is evaluated, and if that evaluation is true, then I will run the expression inside the while loop. And I will keep running this until the logical test evaluates to false. So here we go. Here's a little example. I'm going to start with x equals 5. Now, while x is less than 100, do the following things. So while x is less than 100, I'm going to print out x, and then I'm going to double x. And then I'll go back up to the top of the loop and evaluate my test expression again. So then I'll say, is x less than 100? If so, do the following. So what'll happen is when x is 5, I'll print out 5, then I'll double it to 10, check to see if 10 is less than 100. It is. Then I'll print out 10, double it to 20, etc. So what happened is that when x was equal to 80, then I printed out x, then I doubled x to 160, and then I went back up to the top of the while loop, and then I said, is x less than 100? The answer is false, and so I dropped out of the loop, and now we are done with the while loop, and x is 160. A for loop allows us to repeat a chunk of code a certain number of times. In R, the way that this works is this sort of format where I've got some index variable that gets created, and what'll happen is every time through the loop, it'll take a value inside this vector, starting with the first value. So if I have a vector that is 1 through 10, so in this case, I have a vector that's 1 through 10. And so the first time through the vector, I will be 1 and will do whatever happens down here. And then the next time through the loop, I will be 2 because that's the next element in this vector. Then I will be 3 because that's the third element in this vector. And each time we run this, we will get a different value of I inside this print statement. As a practical example, let's imagine what we need to do a bootstrap. So the way that I like to write a for loop is I like to think about, let's write the body of the for loop first. So the very first thing that I do is I figure out something of interest. And in this case, I've got a boot statistic that is 74.6. Now every time I run this code, this is going to change. And you can see my value is changing 75, 77, 74, 76. It keeps changing. Now, very typically inside of a for loop, I want to be able to save whatever the calculation is that I've just done. And so what I'm going to do is I'm going to take this boot statistic and I'm going to give it a new home. So I'm going to call this thing sample distribution, and I'm going to, at the very beginning, make a data frame that has no values in it. So notice this is a data frame with 0 rows. So now what I'm going to do is I'm going to run my code, and now I'm going to save my result using this rbind. Now remember, rbind takes a data frame and squishes this second thing on the bottom. So because there's nothing currently in sample distribution, then I'm just going to take this boot statistic and squish it on the bottom and end up with a data frame that has 1 row now. So now I've got 1 row in my data frame. I'm going to go ahead and do this again. And now I have 2 rows. Do this a third time, and now I've got 3 rows. All right, fabulous. So the guts of my function now work. And so the final thing that I do when I'm writing my code is then I will actually add this for I in 1 to 1,000 and wrap everything inside these curly brackets. So typically when I write a for loop, I write the inside first, and then once the inside works, I'll write the outside. And it takes a little while because in R, for loops are slow. For you computer scientists, for loops are the slowest thing that you can do in R. Even though in C or C++, for loops are your first tool to solve a problem, in R they should be your last tool. All right, so now I've made a sampling distribution, and we can make a little graph just because that's always a good thing for us to do. Next, we want to talk about building functions. Now, one of the reasons why I want to build functions is that I don't want to deal with the details and the fiddly things about doing some sort of algorithm or procedure, and instead I want to abstract away the details and only worry about sort of the big picture ideas. And in fact, our graphing software that we just looked at does that by just saying, here's the data, here's the relationship, and here's the geometric way to do this. But all the fiddly things are taken care of for you. So what I want to do is I want to talk about how to build a function yourself in R. The base way to make a function in R is that you're going to decide on your function name and you're going to assign it the output of this function. And so it turns out that there's a function named function that creates functions. It's a little confusing, but this is the way that we define things. So your function is going to, in this case, it takes 3 arguments that I've decided to call, just for the sake of argument, argument 1, argument 2, and argument 3. And then down in here, inside the body of the function, you're going to do whatever logic you want to do, and then you're going to return some value so that the output of this function is going to be either a vector or a data frame or something like that. So this is what a function looks like in R. So imagine that I'm interested in calculating the coefficient of variation. And the coefficient of variation is to take the ratio between the standard deviation of a vector of data and it divide by the mean of it. So in this case, I'm going to have an input of x. And x could be anything that the user wants to put in. But inside my function, whatever the user inputs, I'm going to just rename that thing to be x. And I'm going to have a little chunk of code that says, take the standard deviation of this vector x, and then divide by the mean of the vector x. And I'm going to call this my output value. And then at the very bottom of my function, I'm going to return that. And what's going to happen is that we are going to have a function defined, and over here you can see in my environment we have defined this coefficient of variation function, and I can pass it whatever vector of numbers that I want. So I could pass it this coefficient of variation and I could send it in the vector 6, 8, 10, and it'll gladly calculate the coefficient of variation. The idea is that this allows me to build up more and more complicated programs where I can abstract away the details and only concentrate on sort of the big picture questions later on. So that's creating a function in R, and that wraps up chapter 6, which is sort of flow control within R. We'll see you in the next lecture, and have a great day.